Hello guys, I'm Sheldon. Welcome back to Classifying Cats and Dogs in PyTorch. This is episode 3, Building CNN. First of all, I'll briefly talk about what the heck is a neural network. How does it work? Some of you may know that everything in the world can be described with math. That is why physicists and some scientists are so crazy about math all the time. And literally anything can be described with math. So, for example, for the apple falling on Newton's head, you can describe it with this equation. However, let me offer you a harder question and more abstract question that why my girlfriend is mad at me. I really do not know. But fortunately, I can analyze my behavior. Like, I can think about what I did in the morning and at noon, afternoon, evening. What is the most likely thing that can drive my girlfriend crazy? Right? So it means we can analyze its components to see what is the most important part that can define something. It's a little bit like Fourier series. To make up this function, you have to analyze what kind of components that you need to make this up, right? So this is how the convolutional neural network works. Let's take a look into the first picture. Picture A, there is a spider standing on a leaf. So what we want to do is to perform convolutional operation on this image and generate a bunch of images. And each image will pick up some detail information of the first image. For example, for the first one, probably it picks up the long object on this image. It's like probably this little edge is quite long. The leg of the spider, of course, is quite long. So, in the second image, it picks up something that probably has a round shape. So, probably the body of the spider is a round shape. So, in the next layer, it picks up some detail information of the first layer. So, it's like in the first image, it picks up some detail information of the first image of the first layer. Is like it picks up a thin and long object of the first image. It probably picks up the legs of the spider, and so on and so on. So it gathers a lot of detailed components information in the last layer. So after convolutional layer, there is a classification layer which maps the information of the convolutional layer into some numbers that makes prediction. And we train this network to make them find correct detailed information of the image. That is basically how the neural network works. Alright, so we got a lot of codes to do. Let's start coding now. Okay, so now let's back to PyCharm. So this is the script from the last tutorial, and we're gonna make a new one, which is called a network. Alright, probably network. That's it. First of all, so let's make a class named network. We have to inherit from something, but let's do it later. So I want to. So we better first of all initialize the network first. Okay, let's import some library first. So first of all, let's import PyTorch. Actually, I want to import some components from PyTorch NN in this module. And first of all is the module. We have to build our network class, which is inherited from this module. The first thing you want to do when you inherit something is call the father's init function. So it's like this. It's like you have to call the network, self, and init. Alright, so I'm planning to build 3 convolutional layer and 2 linear classification layer. So this is how you want to do it. So first of all, we have to name some something like this, okay? The first convolutional layer. So here we have to import another class. Is actually called convolutional 2D because we are using 2D data to train. So it's conv2D. So now we have to specify some params. The first one is the in channel. It means the input channel. So we're actually using RGB for our little experiment. There are 3 channels. So the out channels, well, this really doesn't matter how many channels you define, but probably 64. Probably 64 is okay. It's like not a lot, but not too less. That's basically what you want. So for kernel size, so this is what's bad about neural network. You actually don't know what to define. You just randomly define some params and train and test it to find the best one. So the size of 5 is not bad in my experience. So we're gonna make another 2 layers, the second layer and a third layer. So here's the tricky thing. To build a second layer, you have to match the in channels of the second layer to the out channels of the first layer. So here is gonna be 64. Basically, what you want to do is to enlarge the channels at the beginning. So the out channel is gonna be 128, probably. That's for good. So the kernel size, let's change it to 3. So let's define the third layer. So the in channels equals the out channels of the second layer. So what you want to do is, like I said, enlarge it. Let's double it to 256. Alright, this looks fine. So the next thing to do is to define the fully connected layer, which is as known as the linear convolutional layer. You have to import the linear from this module again. Okay. Linear. So also, you have to define input and the output. But here is a tricky thing. Let me just demonstrate for you. First of all, let's just put these numbers in the out channels into the in feature, so it matches, right? So what you want to do in the fully connected layer, which is known as the linear classification layer, is to make it smaller and smaller in each layer. So we want to make it like 128, and you want to make the second layer even a little bit smaller, probably 64. So we want to name the third layer as the out layer. So we want to match the out feature to 2. So it's basically a binary number. Is not exactly a binary number. So the output is gonna be either cat or dog. So what you want to do is to output 2 features. So here is another function that you want to implement, is the forward function. So now you want the x, which is the input. In the forward function, you want to describe how you want the images pass through the neural network. So in the first one, it passes through convolutional layer 1. Alright, so it's gonna be x. It outputs x. So in a second, we just wanted to pass through all the convolutional layer and all the fully connected layer. But between them, we want to make some changes. We want to make it better. So between convolutional layers, you can insert some layers that may improve the performance of a neural network. The first one I want to introduce to you is the max pooling layer. Max pooling. So we want max pooling x, but we still don't have this max pooling in our class. So we want to define this. We want to import something else, which is called max pooling 2D. I explained this before. That is simply because we're using images, which is 2D. So that's it. That's what we want. So there is another function you want to import, which is the ReLU function. Function is in the functional. This ReLU function played a role as the activation function. It simply activates the neural networks, and concretely, it's squeezing the value of each convolutional layer to between 0 and 1, and it would be better for computation and even for performance. So here's you want to pass through the ReLU function. So I kind of want to make it pass through these two layers, and for the fully connected layer, we want it to pass through the ReLU function between each layer. So for the output layer, we simply returns it. It takes the output of this layer as the output of this network. So now what we want to do is to pass the image into the neural network. Okay, so remember last time we built this little image loader? We want to copy and paste it here. Don't forget to import everything from the image loader. That's how you import everything from it. What I want to do first is to take some images from it. We want to use this next function to make it generate a bunch of images. Alright, so what we want to do is to make a instance of the network. This is easier than you thought. So output, the network is like a function. Oh, it's images. So pay attention here. The images is a list. The first item of it is the images. So let's run it to see what happened. Let's print out the output. Okay, alright, here it gives some. Alright, so here it complains something. First is about this convolutional layer 2. Alright. It's probably. It's gonna be here. I got a little typo here, and you should place the convolutional layer 3 here. Alright. Let's run it again. So we complain about the conjunction between the convolutional layer and the fully connected layer here. So it's saying that in the fully connected layer first here, it doesn't match. The size doesn't match. So this is simply because that the convolutional layer takes a image as a unit, but the fully connected layer takes a pixel as a unit. So you have to multiply by the image size of the convolutional layer and the channels, so that is the size of the fully connected layer, or it will complain something like this. So to solve this problem is actually very easy. You don't have to calculate it by yourself. You have some tool from the PyTorch which can help you do the job. So this little function is called adaptive average pool. It's also 2D. Alright, so now let's make a adaptive pooling. AD pool. Okay. Alright, so in the adaptive average pooling, what you want to do is to put the in feature of the first fully connected layer. So it will automatically calculate a difference between the convolutional layer and a fully connected layer and adapt it. So what you want to do here is quite easy, but a little bit tricky. So you want to insert this adaptive pooling layer between the convolutional layer and the fully connected layer here. So now you want to stretch the output of the convolutional layer into one-dimensional data. This is how you want to do it. You want to use the view. It's actually okay. So you want to do it like this. So this is how you stretch it out to one-dimensional data. There's another thing I want to do, is to put a dropout layer between them. This can help improve the performance of the network. So let's run it again and hopefully it's gonna work. Alright, so this is gonna be the output of the network. Oh, there's a lot. So let's take a look at the size of it first. Okay, so there's a little bug in it. It shouldn't be like this. It should be the size of 10 by 2. It represents 10 images and 2 output numbers. So the problem is here. You should squeeze it. This is how you eventually squeeze the data into one-dimensional size. Okay, let's run it again and hopefully it's gonna give us. You're killing me. What's happening is like this. What we want to do with this adaptive average pooling is to make it stretch into one-dimensional data. So actually here we don't want to use two-dimensional. What we want to use is one-dimensional, and we want to import the one-dimensional one. So let's run it again. So it gives us 10 by 2. The size of the output is 10 by 2, which is nice. Alright, so let's run it again and see what it gives us. Okay, so this is the first number is gonna be the probability of it being a cat. The second one is the probability of it being a dog. So after training it, it would output digits like here 1, 0, meaning that it should be a cat or dog. So as you can see that this means this is gonna be the probability of it. And what you can see is this is still negative. So what you want to do is to wrap the output with a ReLU function, which is the activated function. So it will become positive, meaning the probability of the object being cat or dog. So this is the video of today. In the next episode, I'll teach you how to actually train the network we built today. So if you enjoyed this video and probably learned something, please thumbs up and subscribe. I'll see you next time. Bye.